Hi, in this video I will explain in brief what are hidden Markov models and how to use them to do parts of speech tagging. So first, let's see what is a Markov process. It is also known as Markov chain. So there is a sequence of events E1, E2, E3 and so on, and we need to find the probability of this sequence of events. Now note that these events are observable, that is we can see these events occur, and these events are random variables which take values from a set of values. Each of these events can start the sequence with some initial probability, and which event occurs after an event has occurred depends on transition probability. So in this image, you can see the events are represented by the circles, and the transition between events are shown as directed arrows. And the labels on the arrows represent the transition probability. So this arrow here, it means that E2 occurs after E1 with probability P1. So the Markov process depends on Markov assumption, which states that the probability of occurrence of an event in an event sequence depends on immediate previous event only. So if you have a sequence like this, E1, E2, E3, E1, E4, then the probability that the next event will be E2 depends only on the last occurred event, that is E4. So it is given by this expression. So P of E2 given E1, E2, E3 and so on till E4 equals P of E2 given E4. So now let's see what are hidden Markov models. So we have a sequence of events like in Markov chains, and we also have initial and transition probabilities. Now here the events can cause some observations, and these observations occur with an emission probability. So the observations are emitted from these events. Now note that we can see the observations only. The events that caused those observations are hidden. So in the image, these dotted arrows, these are the observations that are emitted from these events, and the labels here, they represent the emission probability. So this arrow here, so it means that E2 emits O1 with some probability Q1. Now the hidden Markov models also have the same Markov assumption that was there in Markov chains for these events, that is the probability of occurrence of an event. It depends on the immediate previous event only. So that is same. So what is new is something called output independence, which means that the probability of any output observation that depends only on the event that caused it and not on other events or any other observations, which is given by this expression here. So we can solve three types of problems using hidden Markov models. The first one is given an observation sequence and model. We need to find the probability of occurrence of that observation sequence. The second problem is given an observation sequence and a model. We need to find the sequence of events that best explains these observations. And the third problem is we need to adjust the parameters of the model in order to maximize the probability of occurrence of that observation sequence. So these are some references which you can read in order to know more about hidden Markov models. So first two are the papers, quite old papers, but they are quite good, and they explain in detail about hidden Markov models. And the last one is a chapter from book Speech and Language Processing by Jurovsky and Martin. So let's see what is parts of speech tagging. So assume that you have a sentence like this, that cute dog is running behind a ball. So what you need to do, you want to find the elements of this sentence as per the English grammar. So you want to find out what is a determiner in this sentence, what is a noun, what is a preposition, what is an adjective, and so on. So for this input sentence, we have these parts of speech tags. So our task here is given a sentence of words. We need to assign a parts of speech tag to each word. Now, do you recall any problem of HMM which we can use to solve this task? I will give you 2 seconds to think about it. So The answer is the second problem of hidden Markov models. So given a sequence of observations, that is words, we need to find the events that caused it, that is the pause tags. So for HMMs, we have this information available here. The states or events, these are the pause tags, that is nouns, adjectives, prepositions, and so on. The observations are the individual words of a sentence. For example, if the sentence is the cake is delicious, then the individual words are the observations. The initial probability is the probability that the sentence begins with a particular tag. Transition probability is the probability that one tag comes after another. And the emission probability is the probability that a word has a particular tag. Now, how pause tagging using HMMs work? First, we need to train the model, which involves computing transition and emission probabilities matrix. Then we find the pause tags, where we use Viterbi's algorithm that uses dynamic programming. It has two passes, forward and backward pass. In forward pass, we find the best possible path, that is the path to each node with the lowest negative log probability. And in backward pass, we reproduce the path, that is we backtrace. Now note that this may not be exact and the actual implementation may differ. If you want to know more about pause tagging and if you want to implement this yourself, then please refer to this document here. In the next video, I will show you how to implement pause tagging using MLPack. Thank you.